In the previous video, we discussed about different types of relations, correct? We discussed about reflexive, symmetric, and transitive. And when you have all of them, we call it as an equivalence relation, correct? Let's see one simple example and understand how do we do, okay, it is reflexive, it is symmetric, or any one of them, okay? See, the example will go something like this. Say we have set of straight lines. All right, let's say L is the set of straight lines. So, set of straight lines in a plane. Okay. Now, when you have set of straight lines in a plane, now let's be very specific and particular about it. Let's say I'll say set of straight lines in a plane and that too which are perpendicular. Okay. So, set of straight lines in a plane which are perpendicular. So, when we say when they are perpendicular, let's see whether it is reflexive, symmetric, transitive, equivalence, everything. Now, when we say reflexive, so reflexive is what? So whenever we talk about a reflexive, we have A belonging to A, then A comma A should belong to R, isn't it? Okay. Imagine you have one line. Okay, one line. Let's call it as L1. So L1 belongs to L. Correct? It's a line which belongs to L, set of lines in a plane. Now, when I say set of lines in a plane, perpendicular. So, when I say L1 comma L1, okay, L1 comma L1, can the line be perpendicular to itself? Is it possible? Remember, we are defining the relation, correct? What is R? R is such that, so we have L1 comma L2, such that L1 is perpendicular to L2. Correct? This is what we mean by the relation, correct? So, in this case, when we say L1 comma L1, the line cannot be perpendicular to itself, correct? So what we can say is that L1 comma L1 does not belong to R. This implies L is not reflexive, correct? So same thing if you do for symmetric. See, for symmetric we need two, L1 and L2, correct? See, if L1 is perpendicular to L2, then obviously L2 is perpendicular to L1, is it not? Very simple. So we can say that L1 comma L2, this implies L1 is perpendicular to L2, and when you say L2 comma L1, this means L2 is perpendicular to L1. So this is definitely possible, correct? So we can say that R, or in this case, so here I think this should have been R. The relation is not reflexive. So here R is symmetric. The last being transitive. See what we have for transitive now. For transitive, if L1 is perpendicular to L2 and L2 is perpendicular to L3, we need to check if L1 is perpendicular to L3 or not. Logically think, is it possible? See, think of it like this. Say this is L1, perpendicular to it is L2. Now, perpendicular to L2 is L3, correct? So, L1 comma L2 is represented by this orthogonal condition, and L2 comma L3 is given by this orthogonal condition. But if you look at it, L1 is parallel to L3, correct? So what we can say, this implies that R is not transitive, because L1 comma L3 does not belong to the value of that particular set what we have. See, this is an example how we show that it's reflexive, symmetric, transitive and all. So in the next upcoming videos, you will see different problems based on the same concept. So in the next one, we'll start with problems.